Sentinel tank script, the forbidden Australian tank built. When Britain could not spare resources for Pacific defence, Anzac war weapons. Approximately 3,000 words, TTS optimised revised version. Factual corrections applied. February 1942. Singapore has fallen. 15,000 Australians march into captivity. In Canberra, the panic is raw. Britain cannot spare armour for the Pacific, but in the Sydney Railway Works, engineers begin doing something remarkable. They start casting the hull of a tank their nation has never mass-produced. HMS Prince of Wales and HMS Repulse had already been sunk by Japanese aircraft 2 months earlier. The Singapore strategy, which Australia had invested in since the 1920s, proved worthless. Churchill called it the worst disaster in British military history. The tank taking shape in that Sydney foundry was not a copy of a British design, not an American import. It was the first mass-produced, purpose-designed Australian tank, the Sentinel. Australia's answer when Allied supply lines could not deliver. This is the story of how Australian engineers achieved a genuine industrial first, how they solved impossible problems with improvised solutions, and why the tank they built never fired a single shot in anger. The crisis that forced Australia's hand began long before Singapore. In June 1940, Germany had just conquered France. Britain was evacuating Dunkirk. Prime Minister Robert Menzies understood immediately what this meant for Australia. If Britain fell, or even if Britain simply had nothing to spare, Australia would face Japan alone. A general staff target was set in 1940, 859 tanks by the end of 1941. The number sounds absurd now, and it was absurd then. Australia had no tank factories, no tank designers, no experience in armoured vehicle mass production. The country manufactured cars, railway locomotives, and agricultural equipment. Tanks were an entirely different engineering challenge requiring specialised knowledge that barely existed in Australia. The problem was straightforward. Britain could not send tanks. Every vehicle rolling off British production lines was needed for home defence. The Afrika Korps was pushing toward Egypt. German invasion of Britain remained a genuine possibility through 1940 and into 1941. When Menzies asked London for help, the response was sympathetic but firm. No tanks could be spared for the foreseeable future. America offered a partial solution. Light III tanks would eventually arrive, but not until September 1941. And light tanks were not what Australia needed. Japanese forces were fielding medium tanks with armour that light tank guns could barely scratch. Australian forces needed something that could match them and defeat them. The strategic calculation was simple. If Japan invaded Australia, and after Pearl Harbor this seemed plausible, convoys of equipment might never get through. The sea lanes between America and Australia stretched thousands of kilometres across waters increasingly dominated by Japanese submarines and aircraft. Australia needed indigenous capability. The country needed to build its own tanks. The only option was local manufacture. But how do you build a tank when you have never mass-produced one before? You ask someone who has. In August 1940, Menzies sent a telegram to the British War Department requesting a tank design expert. Contrary to the myth that sometimes circulates, Britain did not oppose Australian tank development. Britain actively assisted. Colonel W.D. Watson of the Royal Artillery Technical Section was dispatched immediately. He arrived in Australia in December 1940, having stopped in the United States to study the American M3 medium tank alongside Australian engineer Alan Chamberlain. Watson brought something invaluable: experience. He had spent years working on British tank designs. He understood what worked and what did not. More importantly, he understood that Australia could not simply copy an existing design wholesale. The country lacked the specialised machinery, the trained workforce, and the raw materials that British and American factories took for granted. Any Australian tank would need to be designed around Australian capabilities and Australian resources, while drawing on lessons from British and American experience. The solution Watson developed was elegant in its pragmatism. Take the best ideas from worldwide tank design, adapt them for Australian industry, create something new that Australian factories could actually build. The formal specification came in November 1940. The tank would weigh between 25 and 30 tons. It would carry a 2-pounder gun, the standard British tank weapon of the era. Armour would reach 50 millimetres. Top speed would be 30 miles per hour. And critically, the dimensions would fit Australian railway gauge, allowing tanks to be transported by rail across the continent without modification. Watson assembled a team of extraordinary talent. Robert Perrier, a French tank expert who had previously worked at Hotchkiss, arrived via Japan after Pearl Harbor. He had been sent to Japan by the French government in 1940, then made his way to Australia when war engulfed the Pacific. Perrier brought knowledge of French casting techniques and suspension design that would prove essential. Alfred Reginald Code, an engineer from Michel's Crankless Engine Company, took charge of production coordination. Prime Minister Menzies gave Code unprecedented authority, power that bypassed both the Ministry of Munitions and Army hierarchies, to fast-track production decisions. More than 300 direct contractors and over 200 subcontractors would eventually participate in the program. The first major challenge was armour. Australian steel mills had never produced armour plate of the quality and thickness required for tank construction. The standard alloys used by British and American manufacturers required nickel, which Australia did not possess in sufficient quantities. Importing nickel through submarine-infested waters was impractical at best and impossible at worst. The metallurgical team developed locally sourced alloys to meet armour requirements. According to some sources, they exploited Australia's abundant mineral resources, including zircon sand deposits along the eastern coast, to create steel formulations that could substitute for scarce imported materials. The exact specifications remain a matter for archival research, but the practical result was clear. Australian industry produced armour plate that met military standards using predominantly local materials. The second challenge was the hull itself. Welded construction, the standard method used by most tank manufacturers, required specialised welding equipment and highly trained welders that Australia lacked. Training welders to the required standard would take months that the country did not have. Perrier proposed casting instead. French tanks like the Hotchkiss H-35 used cast armour sections bolted together. But Perrier suggested something more ambitious. Cast the entire hull as a single piece of steel. No welds, no bolts. One continuous casting. No nation had achieved this at such scale. The technical challenges were immense. The casting would weigh several tons. Any flaw in the pour, any air bubble or impurity or cooling irregularity would ruin the entire piece and waste weeks of effort. Sydney foundries took on the challenge. They installed electric tempering furnaces and developed new pouring techniques specifically for this project. By October 1941, they succeeded. According to Tank Encyclopedia, the world's first single-piece cast tank hull emerged from Australian foundries. It represented the largest and most complex metal casting yet produced in Australia. The third challenge proved the most creative. Every tank needs an engine powerful enough to move its weight at combat speed. The preferred options, Pratt & Whitney Wasp radials and Gerbison diesels, were completely unavailable. All Australian Wasp production went to aircraft. The country desperately needed fighters and bombers to defend against potential Japanese air attacks. Diverting engines to tanks was strategically unthinkable. Watson's team found an unexpected solution in automobile showrooms. Cadillac Viz 8 engines were available through General Motors Holden in Melbourne. These 346 cubic-inch flathead engines were designed for luxury cars, not combat vehicles. A single V8 produced only 110 horsepower, nowhere near enough for a 30-ton tank that required at least 300 horsepower to achieve acceptable performance. But what if you used 3 engines together? The engineers arranged 3 Cadillac V8s in a cloverleaf formation. 2 sat side by side at the front. 1 sat centrally behind them. Each retained its own crankshaft and cooling system. 3 separate drive shafts led to a common transfer box beneath the turret basket. Combined output reached 330 horsepower, enough to move the Sentinel at 30 miles per hour. It was unconventional, it was mechanically complicated, it worked effectively for the intended role. General Motors Holden assembled the power packages at their Melbourne facility, delivering complete engine sets ready for installation. The first prototype, designated E1, was completed in January 1942. In February, the tank received its official name, Sentinel. By August, serial production began at the Chullera Tank Assembly Shops, a purpose-built facility constructed by the New South Wales Government Railways and modelled after American tank arsenals. Now, before we see how this design evolved and what happened to the programme, if you are enjoying this deep dive into Australian military history, consider subscribing. It takes a moment, costs nothing, and helps the channel continue producing this content. Now, back to the Sentinel. The AC-1 that rolled off the production line was an impressive achievement by any measure. It weighed 28 tons and carried a crew of 5. Armour protection reached 65mm on the hull front, angled at 30 degrees for an effective thickness of approximately 75mm. The 2-pounder gun was adequate against Japanese armour, though already becoming obsolete against the heavier German tanks Australian forces faced in North Africa. But Watson and his team were already looking ahead. The 2-pounder was insufficient for future requirements. Australia needed heavier firepower. In June 1942, engineers mounted a 25-pounder gun howitzer on the E2 prototype. The test firing succeeded. This variant became the AC-3, nicknamed Thunderbolt. The 25-pounder offered genuine hitting power, capable of destroying bunkers, fortifications and hardened positions that the 2-pounder could barely scratch. Then came the breakthrough that attracted significant interest. According to Tank Encyclopedia, in November 1942, engineers test-fired a 17-pounder anti-tank gun from a Sentinel hull. The 17-pounder was one of the most powerful anti-tank weapons of the entire war. Its 76mm projectile left the barrel at velocities exceeding 2,900 feet per second. It could penetrate 120 to 208mm of armour at 1,000 metres, depending on ammunition type. At the time of this test, no Allied tank mounted such a weapon in production. The testing methodology demonstrated Australian ingenuity. Before mounting the actual 17-pounder, engineers needed to verify the hull could withstand the recoil forces. They fitted two 25-pounders side by side and fired them simultaneously by lanyard. This simulated recoil forces exceeding what the 17-pounder would produce. When the hull handled that punishment without structural damage, they knew it could take the real gun. The AC-4, as this 17-pounder variant was designated, could have been among the most powerfully armed tanks anywhere in the world in late 1942. The British Sherman Firefly, mounting the same gun, would not enter production until early 1944, more than a year later. According to Tank Encyclopedia, Colonel Watson returned to England in late 1942 and shared drawings and information from the Australian work. This contributed to discussions that later supported 17-pounder mountings in Allied tanks, including the Firefly program. 510 AC-4s were authorised for production. None were ever built. The program that had achieved so much ended with brutal swiftness in July 1943. The reasons were pragmatic rather than technical. The Japanese invasion threat had lessened dramatically. American forces had turned the tide at Midway and Guadalcanal. Australia was no longer fighting for survival. More importantly, American factories were now delivering tanks faster than Australia could ever hope to match. 777 M3 Grant and Lee tanks arrived directly from the United States. M4, Shermans followed in increasing numbers. British Matilda tanks came from Middle East stocks. These were proven designs with established supply chains and readily available spare parts. Crews could train on them immediately using existing manuals and procedures. The Sentinel, for all its achievements, had problems that required resolution. Engine cooling remained inconsistent in hot conditions. The turret traverse mechanism needed refinement. Road wheel rubber wore faster than specifications predicted. These issues were fixable given time and resources, but those resources could be better spent elsewhere when proven alternatives were arriving by the shipload. When production ceased, 65 AC-1 Sentinels had been completed, carrying serial numbers 8001 through 8065. One AC-3 Thunderbolt prototype existed, serial number 8066. 150 additional AC-3 hulls had been cast, and 25 tanks were in various stages of assembly. All work stopped immediately. The 65 Sentinels that emerged from Chullora never saw combat. According to the Australian War Memorial, they were used for evaluation and training purposes only, never issued to operational armoured units. The closest they came to action was appearing in the 1944 film The Rats of Tobruk. Director Charles Chauvel modified a squadron of Sentinels to resemble German panzers for battle scenes. They fired blank rounds at Cronulla sandhills south of Sydney, standing in for the Libyan desert. Peter Finch and Chips Rafferty starred. According to researchers, this appears to have been the only time a squadron of Sentinels was assembled for any purpose. In 1945, the Commonwealth Disposals Commission dismantled and disposed of 63 tanks. Most were sold for scrap metal. Some hulls were converted to agricultural tractors by enterprising farmers. How does the Sentinel compare to what Australia actually used in combat? The Matilda II that Australian forces took into the jungles of New Guinea and Borneo carried the same 2-pounder gun as the AC I. Its armour was comparable at 78mm frontal thickness. But the Matilda was slow, achieving only 15 miles per hour, less than half the Sentinel's 30 miles per hour top speed. This slowness, counterintuitively, proved advantageous in jungle conditions. Infantry could keep pace with the advancing tanks. The ponderous movement suited close support operations in dense terrain where speed mattered less than firepower and protection. Against Japanese armour, the Sentinel would have been highly effective. The Type 97 Chiha weighed only 15 tons with armour of just 15 to 25mm. The 2-pounder could penetrate that protection at any combat range. The Japanese 57mm low-velocity gun lacked the armour-piercing capability to threaten 65mm of sloped plate. But this comparison reveals the Sentinel's fundamental problem. It was overbuilt for the Pacific theatre. Australian planners designed it to fight German Panzer IIIs and IVs in North Africa and potentially Europe. At 28 tons, it was too heavy for Pacific transport infrastructure, for jungle bridges, for island supply chains. The armour thickness and mechanical complexity exceeded what fighting Japanese forces actually required. Tank archives reached a conclusion that modern historians generally accept. The decision to cease production was correct for Australia. Economics and logistics trumped engineering achievement. 3 original Sentinels survive today from the 65 completed. Serial number 8030 sits at the RAA Sea Tank Museum at Pukapinyal in Victoria. Its triple Cadillac engine has been rebuilt, and it runs on special occasions like Cambrai Day. Serial number 8049 rests in the Tank Museum at Bovington in England, sent for evaluation trials in 1944 and never returned to Australia. Serial number 8066, the sole Thunderbolt prototype with its 25-pounder gun, is housed at the Australian War Memorial's Trelaw Resource Centre in Canberra. The Sentinel represents something remarkable in military history. In 36 months, engineers with no tank mass production tradition created a vehicle incorporating genuine innovations. The world's first single-piece cast hull, an ingenious triple-engine solution to power plant shortages, one of the earliest successful 17-pounder mountings. The AC-4 might have been among the most powerfully armed tanks anywhere in late 1942. Yet the story confirms that wars are won by logistics, not engineering achievement alone. When American factories could deliver proven tanks faster and cheaper than Australian factories could develop new ones, the correct decision was cancellation, however painful for the engineers who had accomplished so much. The 66 Sentinels that emerged from Chullora represent not failure but capability demonstrated and crisis averted. Australia proved it could mass-produce tanks when the need arose. Then it wisely chose not to continue when better alternatives became available. When Britain could not spare resources and America had not yet arrived in strength, Australian engineers built their own solution from railway workshops and automobile engines and local materials. The Sentinel never fired a shot in combat, but it stood ready, and that readiness, that demonstrated capability was